Alright guys, here's the last video for the cumulative test number 3 review packet. We're going to start with number 20. Number 20 just says solve, but I noticed that a fraction equals a fraction. And no matter how crazy the fractions are, when that's true, the diagonals are equal. And so this is a situation that if a fraction equals a fraction, we cross multiply. And I know that this topic will never go away. It comes up in geometry quite a bundle. So if I cross multiply, we would get 10 times all of x plus 3 equals 6 times all of 4x minus 6. And yes, you could have had this whole thing on this side of the equals and this whole thing on this side. It doesn't make a difference as long as you're careful with your parentheses. So if I distribute on both sides, I would get 10x plus 30 equals 24x minus 36. So if I want to get my x's together, you can solve it a different way than me, but I'm going to subtract my 24x. And if I do that, I would get negative 14x plus 30 equals negative 36. If I continue to get x alone and subtract 30, I would get, I would get negative 14x equals a negative 36 plus negative 30 is a negative 66. So if I divide both sides by negative 14, it doesn't look like 14 goes in evenly, but I do get negative divided by negative. I do get a positive 66/14. And if I want to leave my answer as a fraction, if I recognize that both of these are at least divisible by 2, I can get x to equal 66 divided by 2 is 33, 14 divided by 2 is 7. I can't take anything else out. So make your life easy and leave your answer as an improper fraction. Speaking of fractions, the good times continue to roll with number 21. As I said during the first week, fractions shall never go away. You're welcome. So if we look at 21, I just rewrote the problem for room. This is not, let me repeat, not a situation we're going to be using the reciprocal, because the 3/4 is not multiplying the x, it's being added to the x. So the only way we can get rid of it is to subtract 3/4 from both sides. So I'd have x alone equals negative 7/8 minus 3/4. And this is a situation when I'm combining the two fractions that I need a common denominator. Everyone's favorite. My common denominator between 8 and 4 is 8. So you don't necessarily need to multiply both fractions. If you notice instead that this fraction just needs a 2/2 to get this denominator to be 8, that is the faster way to do the problem. So you have negative 7/8 minus 6/8, which is where I got my answer of negative 13/8. And remember, please never change the denominator. You only combine the numerator. 22. Solve the following inequality. This problem is either the same or very similar to the one that we did in class on the cumulative review homework last week. I noticed that a lot of you got this wrong during our in-class multiple choice practice, so I want to do it again here. Remember, the word and means overlap. So in the end, we only want the answer that the overlap exists. So if I solve both of these separately, the first one, I need to add 4. Negative 3x is greater than or equal to negative 9. If I divide both sides by negative 3, I divided by a negative, so to keep the statement true, I must flip the inequality sign and have that as a positive 3. So either x is less than or equal to 3, and if I solve this second one, unlike number 21, where I had a big old plus in the middle, so I had to subtract the 3/4. For this problem, it is 2/3 times x. So, as we've talked about, I could divide both sides by 2/3, but as we've discussed, that is not helpful to write it like that. Instead, what is extremely helpful is to use the reciprocal. So if I rewrite the problem here, just for room's sake, and I multiply this side by 3/2, I'd have to multiply this side by 3/2. Not negative, so my inequality does not flip, but I have x is less than negative 24 over 2, which is really x is less than negative 12. So this looks like my answer so far, but let's graph it to make sure we know exactly what my answer is. If I put 0 in the middle, I'm going to put negative 12 all the way down here, so I'll put 3 right next door. If I graph both pieces, x is less than or equal to 3, so close dot down. X is less than negative 12, which is open dot all the way down. And if I'm thinking that and means overlap, if I look at the blue and the purple, they start to overlap at negative 12 and then going all the way down to negative infinity. So my answer graphically is the red piece. And technically, algebraically, this isn't my answer. Now that we've done this for longer, I want you to see that technically my only answer is just x is less than negative 12. So this is my answer graphically, and this is truly my answer algebraically. Yes, I know you got this piece, but this is the only place the overlap exists. Number 23. My goal is to solve for x, or get x alone. And I'm keeping with the theme of fractions here to give you more practice. If I'm trying to get x alone, let's first move that unattached 8. So we'd have 4/7 x equals m plus 8. These are not like terms, so let's leave them as we see them. Just like 22, we have a fraction multiplying x. So this is another situation that the reciprocal applies because we are technically dividing by 4/7 or multiplying by the reciprocal. If I want to multiply this entire side by the reciprocal, I need parentheses so that it multiplies what was already there. 7's cross out, 4's cross out, x equals, I'm going to go ahead and bring that 7/4 in the front, so 7/4 times m plus 8. Now, earlier in the year, I left the answer like this, but now that we've been through more of the course, I'm going to keep going because this reminds me of writing equations of lines. So x equals 7/4 m plus 7 times 8, 56, 4 times 1, 4. 56 divided by 4 does divide in evenly. This is 14. So x is 7/4 m plus 14. And so this is how, at this point in the year, I would like your answer to be. Because I recognize that you could have left your answer like this earlier in the year, but now that we're more sophisticated, I do expect this box answer. Okay. The last problem here has to do with the line of best fit. Now, because everyone is going to have a different line of best fit, we are going to be just doing probably point A here in the video. Point B and C, I want you to pick which 2 points you think is best, find your own equation, and we'll talk about this in class once more of you have tried it. But if we at least do part A, and this will be the last one in the video, my goal is to take all this information, plot all the points, and then answer some questions to start. Do you think it's positive or negative correlation? Do you think it's strong or weak correlation? And let's pick a scale so we can best see our information, maybe even draw a line of best fit. So what we're dealing with is years past 1996, how many students per computer were there? So notice, in 1996, when computers were really becoming a new thing in the classrooms, pretty much when I was in elementary school, there was only like 4 computers in the whole school. So it's amazing how times has changed. But in 1996, there were 22 students per 1 computer. But 12 years later, there's only 4 students per 1 computer. So as you can see, computers are getting less expensive and are becoming more available in classrooms. And so what we need to do is graph this information. The years past 1966 would be the x values, and the students per computer would be the y values. So if I'm thinking scale, it looks like I'm going all the way from 0 to 12, and I have the space for it, so I'm just going to go by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, running out of room, 11, 12, 13, 14, and then this last one will be 15. So I went by ones here. And these are little arrows to point down so you don't get lost in it. And this axis would be labeled years past 1996. The y-axis, however, ranges from 4 all the way up to 22. So when I did this problem before, again, it's completely your choice, but I'm going to choose to go by 2s. So let's see if I have enough room if I skip. 2, 4, 6, 8, 10, 12, 14. No, so I have to go by every line, but go by 2s. I'm going to choose 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. I know that's my top, but I'm just going to keep going. 24, 26, 28, 30. So now I'm going to plot by information. So in 1996 exactly, there were 22 kids per computer. 2 years later, there were 16 kids per computer. 3 years later, it seemed to go back up in this particular district to 18. So this is when computers are probably getting better, but people still don't know how to use them best. 4 years later, it changed to 10 students per computer. 6 years later, it reduced to 6 kids per computer. 10 years later, we had 5, which would be right in between here. And then 12 years later, right here, there's 4 kids per computer. And so this information definitely seems to be decreasing. So I would say between the types of positive or negative correlation, I would say that this is a negative correlation. And I'd also say it's decently strong. I would say negative, strong correlation. In terms of what this situation means, it seems to me that every year we pass since 1996, that more students are getting their own individualized computer. So in terms of situations, as the years pass after 1996, it seems that more students get their own computer. Now, the reason I wrote the phrase "it seems" is because this isn't a perfect causation. It seems like more of a correlation, so I'm kind of basing it on the small data set that I have. So we answered the question about, is it a negative strong correlation? We answered what it seems to mean in terms of the situation. The last thing we want to do is kind of to consider what we think a good line of best fit would be. And this is when I'm going to let you decide that. I want you to think about the data that you have here and where you can draw your line to best represent the line of best fit. And once you choose your 2 points, that's when I want you to try part B. Write the 2 points here, find the slope, use one of the points to find the equation, and then after you're done with that equation, I would definitely try part C on your own also. One thing to point out to you, though, that 2016 is a specific amount of years after 1996. So instead of plugging 2016 into your equation, consider that the x value you're going to plug in is 2016 minus the starting year of 1996. All right, guys, again, we will go through this problem in class. I just want to kind of see what you did first before I do it in detail. I hope these videos were helpful, and good luck on your cumulative test number 5.